Under the Enclosure with eMotors Direct.
Hello, and welcome to another episode of Under the Enclosure with eMotors Direct. Today, we are talking about selecting electric motors for hazardous locations. Electric motors are often required at potentially explosive or flammable sites, such as chemical plants, coal mines, or petrochemical plants. Accidents could result in damage, injury, or loss of life. This makes it vitally important to select a motor that won't create an ignition source. Let's take a look at the 4 key criteria used to classify different types of hazardous locations and how electric motors are designed and rated to operate safely within them. Understand the hazard. When selecting a motor for a hazardous location, the first step is to classify the site according to the standards that apply to your local area. In the U.S., hazardous location classification is determined by the National Electric Code, NEC, while the Canadian Electrical Code, CEC, applies to us here in Canada. In practice, site classification is complex and requires a thorough inspection and analysis of every aspect of the motor's environment. Consult the relevant safety authorities in your local area for detailed guidance. The following sections will give you a broad overview of the 4 main criteria used. 1. Class. The class of a hazardous location describes the form that the principal hazardous material takes within it. There are 3 classes, in order of highest to lowest risk of ignition. Class 1 locations contain highly flammable gases and vapors in the atmosphere, which could be explosive when ignited. Examples include petroleum refining plants, gas plants, spray painting facilities, and refueling areas. Class 2 locations contain combustible or electrically conductive dust particles in the air. Materials such as coal dust or flour and conductive particles such as aluminum and magnesium dust can become highly explosive when dispersed in the air at sufficient concentrations. Class 3 locations describe environments where combustible material is present in a larger particulate form, such as filings and shavings, usually settled on surfaces. Examples include industries where the processing of wood or textiles takes place. Number 2. Division. The division of a hazardous location describes the conditions under which the principal hazardous material is present, and there are 2 of those. Division 1 locations designate areas where the material is present under normal operating conditions, either as part of the process itself or during a scheduled activity such as maintenance. Division 2 locations are those where the material is exposed only under abnormal conditions. The material will usually be present in a contained volume, such as inside sealed pipes or tanks, potentially coming into contact with the motor only during an accident, such as a rupture or a leak. Number 3. Group. The group that a hazardous location belongs to represents the behavior of the principal combustible material after ignition. There are 7 groups labeled from A to G. Groups A, B, C, and D describe flammable or explosive gases, vapors, and liquids in order of highest to lowest risk. For example, acetylene, a particularly volatile gas that burns intensely, belongs to Group A, while Group D contains the much less dangerous ethanol. Groups E, F, and G contain combustible dust that would create a Class 2 hazard in order of higher to lower risk. Materials range from aluminum dust in Group E to corn, sugar, and wheat flour in Group G. Number 4. Auto-ignition temperature. It is important to obtain the auto-ignition temperature, or AIT, of the hazardous materials in the vicinity of a motor. This is the minimum temperature at which a material will ignite independently without any other ignition source. As you will see in the following sections, this is a key part of determining whether a motor is suitable for the site. In practice, the AIT value is not simple to obtain, as it depends on environmental factors, such as oxygen concentration and environmental pressure. Mixtures of several different materials can complicate this step even further, and a conservative estimate may be required. Choosing a motor. Once a site has been classified, it is time to choose a suitable motor. Let's look at the types and ratings of electric motors designed for hazardous locations. Motor ratings. Hazardous location motors usually come with a rating for the class, division, and group for which they're suitable. For a long time, only Division 1 motors were rated, so many motors do not have a division rating, as they're rated for Division 1 locations by default. Division 1 motors can operate in Division 2 locations, but may be over-engineered and unnecessarily costly compared to Division 2 rated motors. Why spend more if you don't have to? Electric motors also come with a T-code rating, which specifies the maximum temperature that any part of the motor surface that might become exposed to a hazardous material will reach, including in the event of burnout, power overload, or a locked rotor. This temperature rating must be compared to the AIT of hazardous materials at the site to determine if the motor surfaces pose a risk of ignition. Motor ratings must be authorized by safety authorities such as the Underwriters Laboratories, UL in North America, or the Canadian Standards Association, CSA. Explosion-proof motors. Explosion-proof motors, which are a requirement for Class 1 Division 1 locations, must be able to contain an internal explosion of a specified hazardous material without creating an ignition source for the environment around them. This is based on the assumption that over time, the gases and vapors in the atmosphere around the motor could make their way inside, coming into contact with internal elements that could produce a spark or generate excessive heat, especially during a fault. Explosion-proof motors are designed with thick, hardened cases to contain the pressure of an initial explosion, and they must allow hot gases to escape in a controlled way that does not create an ignition source. To do this, they use flame paths, which are long, narrow corridors through which burning gases can escape while being cooled to a safe temperature. Flame paths are usually built into the shaft or body of the motor. Division 2 motors. These can often be regular TEFC motors, or totally enclosed fan-cooled, that have been CSA approved for use in Division 2 areas. They must include a secondary nameplate with a CSA rating, class division and group ratings, and a temperature code. Dust ignition-proof motors. In Class 2 locations, where the hazardous material is present in the form of airborne dust, a dust ignition-proof motor is required. This type of motor features dust-proof seals and bearings that prevent dust from entering the motor altogether. It's important to determine the T-code rating of dust ignition-proof motors properly. They often accumulate a layer of dust on the outside of the motor body that inhibits cooling and increases the surface temperature. An important point to note: using VFDs in hazardous locations. Variable frequency drives modify the frequency of an AC power supply, enabling speed control of AC electric motors. However, they often create extra heat inside the motor due to the creation of harmonic frequencies in the motor windings. Additionally, when VFDs are used to run a motor slower than the motor's base speed, it can greatly affect the shaft-mounted fan's ability to provide cooling. Explosion-proof inverter-duty motors are designed to work with VFDs while mitigating these heating issues. It is important to keep in mind that these motors must meet the division, class, group, and T-code ratings of the area and be rated for VFD use. So, now that you are familiar with the key concepts used in hazardous location classification, as well as the motors designed for different types of hazards, you've taken the first step towards selecting the right electric motor for you.